Hello and welcome little scientists to this week's episode of Stay at Home Science, brought to you by the South Brunswick Public Library. I'm Allyee, and for this week's experiment, we're going to be taking a regular egg and turning it into a rubber bouncy egg. First, we need to gather our supplies. We'll be needing white vinegar, a clear cup or jar with a wide opening, an egg, optional food coloring, and as always, don't forget to grab a grown-up. To start off the experiment, we're going to grab our glass cup or jar and you're going to place your egg in there. If you have a tall cup, you can use a spoon to help you guide the egg into the cup. And of course, if you break or crack your egg, you'll have to grab a new egg. Next, you're going to grab your vinegar, and you can pour the vinegar in first and then put the egg in, or put the egg first and then the vinegar. It doesn't really matter which way you do it. I prefer to put the egg in first so I know how much vinegar I need to use. You want to make sure that your vinegar is covering your egg. Otherwise, the experiment's not going to go as well. I want you to look at the reaction that we're getting. As soon as we added the vinegar to our cup with our egg, we're getting a chemical reaction. All of these tiny bubbles are forming around the egg, which are then floating to the top and bursting. What do you think these bubbles could be? Well, eggshells are made up of calcium carbonate. And once the acid in the vinegar combines with that calcium carbonate, it's actually producing carbon dioxide gas bubbles. So with this experiment, you can do as many eggs as you like. You can just do one, or I recommend doing at least two just in case one breaks. So for my first egg, I've just did vinegar, but for my second egg, I'm gonna do vinegar and food dye. So I already went ahead and mixed some food dye into my vinegar, and I'm just gonna pour that into the cup. And then I'm gonna place my egg into the cup. Once you have your eggs in your vinegar, now comes the hard part. We actually want to place these eggs somewhere where they won't be disturbed for up to 3 days. That's right, 3 days. Even though this experiment is quick and easy to set up and uses household common items, it takes up to 3 days, so you'll have to be patient. Over the course of 3 days, make sure to check in on your eggs to see how they're doing. All right, little scientists, I'll see you in 3 days. Alright, little scientists, it's been 3 days and our eggs are ready. So the first thing we're going to do is we're going to grab a container and fill it with water. You can also do this over the sink, but if you do, you want to be extra careful with the amount of pressure that's coming out of the faucet. That's why I recommend just grabbing a bowl of water, and what you're going to do is grab one of your eggs and carefully take it out and then submerge it into the clean water. We want to get any of that scum that's forming at the top to come off, and you want to gently rub your egg with your clean water to get off any of the remaining shell that's stuck there. So as you can see, the shell is coming off kind of like sludge. And it's very easy to remove. Just use simple wiping motions and the water. And make sure over the course of those 3 days, when you check in on your eggs, that they have enough vinegar. Sometimes the vinegar levels will drop and you'll have to add more. You want to make sure that your eggs are completely covered in vinegar, otherwise they won't come out bouncy. This one has a little bit of shells kind of stuck on there. I actually noticed on day 2 that my vinegar levels had dropped and that this was exposed to air and not soaked in the vinegar. So that might be why it's getting a little tough to get the shell off. But if you're patient and you keep just scrubbing away gently, you'll be able to take it off. All right. I have my first egg, it's all clean, and I'm gonna put it on this towel just to dry off. Now I have my second egg, And the same thing, just gonna grab it gently. This one's a little harder to grab because of the container I put it in. So that's why you wanna make sure that you have a container that you're able to get the egg safely out of. Just by looking at it, you can feel that this egg, the eggshell, actually came off a lot easier. Yeah, this one needs barely any rinsing. I think that's because I added a lot more vinegar in this one than I did with my first one. All right, so we have our 2 eggs. Our experiment was successful. This is a rubber egg, otherwise known as a naked egg. It's a raw egg that you can now bounce. The eggshell dissolves, leaving behind a soft, bendable, squeezable rubber egg. We can see that the original color of this egg was white, and now it's turned into a translucent color, which means it's see-through. Now, I recommend if you're going to bounce your egg to do it somewhere where it's easy to clean up, like a plate or in a sink. And of course, this is still an egg, so it's still fragile. So I wouldn't recommend that you drop it from a high height unless you're ready to break your egg. So to start with, just start from a low point. And as you can see, we can roll it around and bounce it. Isn't that cool? We can see that our rubber egg got larger when we compare it to a regular egg. Well, how is that possible? Let's discover why as we learn the science behind our rubber egg. Now remember, when we added our egg to our vinegar, we created a chemical reaction. And that chemical reaction, it causes our eggshells to fully dissolve, leaving behind this soft, flexible membrane. Now, the membrane of an egg is extra special because it's semi-permeable, which means it only lets specific molecules through it. Vinegar is made up of water, and that semi-permeable membrane allows that water to pass through and be absorbed into the egg, which then causes our egg to swell and grow in size. This flow of water through a semi-permeable membrane is actually called osmosis. Osmosis works by having those water molecules travel from an area of high water concentration, which was our vinegar, to an area of low water concentration, which was our egg. Osmosis wants there to be an equal amount of molecules on each side of the membrane. Now, what's interesting about osmosis is that it works both ways. So, if you little scientists want to extend your fun with our rubber egg experiment, I have a challenge for you. Once you're done playing with your rubber egg, I challenge you to put it into a cup of corn syrup or honey. What you'll find is that the opposite reaction happens. Instead of your egg absorbing the honey, osmosis is going to allow the water from our egg to move from our high concentration, which is the egg, to an area of low concentration water molecules, which is the honey or corn syrup. So instead of your egg swelling and filling with honey, you'll find that your honey is going to get very runny and watery while your egg shrivels and becomes smaller. Now, if you little scientists do this experiment, I'd love to see how yours comes out and what the reaction is. Now remember, this experiment turns your raw egg into a rubber egg, but that still means it's a raw egg. So, raw eggs, as always, carry the risk of salmonella, which means you have to be careful. Remember to wash your hands thoroughly after completing your rubber egg experiment. All right, little scientists, I moved you in closer so you can see in action our rubber bouncy egg. First, I want to show you our clear egg. You can see the yolk that's still floating in our clear egg. And let's see what happens when we put a flashlight under it. You can see the yolk a lot clearer that way, and you can see that it's still floating in there, and that the chemical reaction didn't affect the yolk inside the egg. Isn't that cool? Let's see if we can see it in our blue egg. Our blue egg is pretty dark, so I'm not seeing it there, but it's still pretty cool. All right, I'm gonna bounce the blue egg, and let's see. So if you're gonna bounce, like I said, I recommend doing it somewhere it's easy to clean up. So you can do it on a plate, on a table with a tablecloth put down, or in your sink. So let's bounce. I'm gonna start off with just a little bit off the ground. And then I'm gonna go a little higher. Whoa, okay. Let's see if we can go a little higher. That was really cool. Thought it was gonna break that time. It broke, but that's okay. And you can see the rubber membrane. Alright, little scientists, thanks so much for joining me on this episode of Stay at Home Science. I hope you enjoyed our rubber bouncy egg experiment and that you try this out at home. If you do, please send us a picture or a video and tag us on social media. Thanks so much for watching, and don't forget to subscribe to this YouTube channel and follow us on our South Brunswick Public Library's Facebook page for more updates and content. Until next time, bye! So squishy! Squish, 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 squish.